Welcome to 6.2 Solving Trigonometric Equations Part 1, Example 5. Solve cotangent x minus rad 3 equals cosecant x over the interval 0 to 2 pi. Now this equation is different because it has a cotangent x and a cosecant x. However, they are not being multiplied by each other. There is an identity that relates cotangent x and cosecant x. We have a Pythagorean identity which states 1 plus cotangent squared x equals cosecant squared x. However, the cotangent and the cosecant are both squared, and in our current equation, neither are squared. One strategy when you have two different trigonometric functions that are related by a Pythagorean identity is to go ahead and make sure that the trig functions are on opposite sides of the equation and square both sides. While squaring both sides is a handy tool for solving, we must be very careful. Anytime we square both sides, we must check our final solutions because this act of squaring both sides often gives us extraneous solutions. As a reminder, I like to go to the bottom of my paper and also write check, so I make sure that I check my solutions at the end. So we now have a reminder to check at the end of our problem. Now let's carefully square this. If you need to, write out cotangent x minus rad 3 times another cotangent x minus rad 3. And on the right, we'll just get a cosecant squared x. So multiplying this out carefully, so therefore we get cotangent squared x minus rad 3 cotangent x minus another rad 3 cotangent x plus rad 9, which is just 3. Combining like terms, the negative rad 3 cotangent x and another negative rad 3 cotangent x can be combined. Since we had negative 1 rad 3 cotangent x minus another 1 rad 3 cotangent x, our middle term ends up being negative 2 rad 3 cotangent x. Now we still have cotangents and cosecants, so now it's time to employ our Pythagorean identity. Since we have additional cotangents in our equation, we're going to want to replace the cosecant squared x with 1 plus cotangent squared x. Now the left-hand side will just drop down. Since we have cotangent squared x on both sides, let's subtract cotangent squared x from both sides to see what we get. And look at that, our cotangent squared x's have canceled out. Now we have negative 2 rad 3 cotangent x plus 3 equals 1. Now this is linear in form since our cotangent squareds have failed. So now we need to isolate the cotangent x. First, we will subtract 3 from both sides. Negative 2 rad 3 cotangent x equals negative 2. Now we will divide both sides by negative 2 rad 3. Let's go ahead and simplify that. The negative 2's cancel, so we're left with 1 over rad 3. So cotangent x equals 1 over rad 3. We could rationalize the denominator, or we could go straight to the triangle from here. Where is cotangent positive? It's going to be in the same quadrants where tangent is positive. So that's in quadrants 1 and 3. Now we can think of cotangent as being x over y. So therefore we could write our x value is 1 and our y value is rad 3. So that's going to be a special angle of 60 degrees or pi over 3. So therefore in quadrant 3, our reference angle is still pi over 3, and whether you use degrees or you go straight to radians, that's going to give us 4 pi over 3. So we get two solutions. X is pi over 3 or X is 4 pi over 3. However, remember, because we squared both sides of our equation, we have to check both solutions. When we go to check our solutions, it's important that we check in our original equation. So we're going to plug it into cotangent x minus rad 3 equals cosecant x. So let's check. Cotangent of pi over 3 minus rad 3 equals cosecant of pi over 3. What's nice is we already have our triangle here. So we could go ahead and finish it with 1 rad 3 and our hypotenuse will be 2. So cotangent of pi over 3 will be x over y, 1 over rad 3, minus rad 3. Cosecant of pi over 3 is the reciprocal of sine, so instead of rad 3 over 2, it will be 2 over rad 3. So let's go ahead and rationalize both 1 over rad 3 and 2 over rad 3. So we get rad 3 over 3 minus rad 3, and we want to know, does that equal 2 rad 3 over 3? So first now we need to get a common denominator. We will multiply top and bottom of rad 3 by 3. So is it true that rad 3 over 3 minus 3 rad 3 over 3 equals 2 rad 3 over 3? Well, we could put a 1 in front of the rad 3 over 3. So when we subtract 1 rad 3 over 3 minus 3 rad 3 over 3, we actually get negative 2 rad 3 over 3, which will not equal 2 rad 3 over 3. When we square both sides, it's actually a sign error that usually becomes the problem where we get extraneous solutions. So therefore, x cannot equal pi over 3. Now let's check 4 pi over 3. To do this, I will go ahead and finish the triangle for 4 pi over 3. So our x is negative 1, our y is negative rad 3, and our r is 2. So we plug in 4 pi over 3 to the x on both sides of the equation. So we're checking, does cotangent of 4 pi over 3 minus rad 3 equal cosecant of 4 pi over 3? So looking at the triangles, cotangent of 4 pi over 3 will be negative 1 over negative rad 3, or just 1 over rad 3. And cosecant is the reciprocal of sine, so instead of negative rad 3 over 2, we actually get negative 2 over rad 3. Again, rationalize the denominators. You might notice that the left-hand side is the same as the left-hand side on the previous check, so we expect the left-hand side to be negative 2 rad 3 over 3. So we get negative 2 rad 3 over 3 on the left, and the same, negative 2 rad 3 over 3 on the right. So this does in fact check out. So our final answer is just 4 pi over 3. So when solving trigonometric equations, the only time where you have to check extraneous solutions is when we square both sides. So once you do that step of squaring both sides, you run the risk that all of this math might have a sign error where a positive is actually allowed to equal a negative, and that's because when you square opposites, you get them to be equal to each other. So when you have an equation with two different trig functions that are a part of the same Pythagorean identity, that's when you want to use that method of getting those functions on opposite sides of the equation, squaring both sides. But you have to be careful that you check all solutions at the end, because squaring both sides often gives extraneous solutions. So our final answer is only x equals 4 pi over 3. I hope you enjoyed this video. See you next time.